Hey everybody! This week we're going to be talking about z-scores. Z-scores are helpful because they help us understand the likelihood that a data point will fall above or below a certain point on a distribution. Remember our example last week of the income distribution of social workers? We're going to use that same example this week, so if you didn't see that video, watch it first. To calculate the standard deviation, we took the mean salary of our friends, subtracted that from each of their individual salaries, squared the terms, added them together to get the sum of squares. We divide by n minus 1, and then took the square root of that number to get the standard deviation of the income distribution of our friends. And it was about 8,758 cents. We could then use the standard deviation to figure out where we were in relation to our friends' incomes. We took the mean difference of our salary, placed it over the standard deviation, and found out that we were about 1/4 of a standard deviation below the mean, right about here, at least in relation to the friends that we spoke to. But how is it helpful to know where we are in a distribution? What does 1/4 of a standard deviation mean? Well, any given point on a distribution has a corresponding z-score. We can use the z-score to tell us what percentage of the points fall above or below the z-score. That could be helpful, in our case, to help us understand what percentage of our friends we earn more than, or what percentage of our friends we earn less than. We take the z-score that we calculated, look it up on the z-table, and we see that 11% of the cases fall between the mean and our z-score. But what does that mean? What does that look like? Well, that 11% is this little rectangular box right there. If we add that 11% to the 50% of cases that fall on the right of the mean, we can see that 61% of the cases are greater than our income, or about 60% of our friends earn more than we do. We can also use the z-score to figure out the opposite. What percentage of our friends earn less than we do? If we go back to our z-table, use that z-score, look it up again, move over one more column, we can see the percent of cases that fall below our negative z-score, and it's 39%. So 39% of our friends earn less than we do. On the distribution, it looks like this. It's that part to the left of our z-score. So our $2,200? Well, at the end it means that 60% of our friends earn more and about 40% of our friends earn less. Not too bad of a place to start as a new employee. Let's review. To calculate the z-score, first, you calculate the standard deviation, calculate the difference between the mean and the data point, divide that difference by the standard deviation, look up that z-score in the z-table, and then determine whether you're reading the percent in the tail or in the mean. Now here's your Media 3 question. If your salary is still $50,000 and the mean salary is $48,000 with a standard deviation of $2,000, what percent of the employees make more than you do? What percent make less? Hint, you don't need a calculator for this one, folks. All right, that's it. Have a great week.